Okay, continuing the section on increasing, decreasing, and the first derivative test, we're going to move to the next example. This particular one says, use the first derivative test to find all relative extrema. Remember, relative extrema is just max and mins for the function. Now let me go back up to our first derivative test. It's right here. And it's like, test the first derivative, look to see if there's a change from positive to negative. If so, then you can determine max and mins from that. So we're going to use that idea and come determine extrema using the first derivative test. So let's start with our function, which given in this one is 2x cubed minus 3x squared. And the first thing we want to do is take the first derivative. Okay, and then we're looking for possible critical numbers, and we know that process is to set the first derivative equal to 0 and factor if you can, which it does look like this factors. It looks like a 6 can be pulled out. And then this can be factored as well, so we'll get 0 is equal to 6. What multiplies to give us negative 6 adds to give us a positive 1. It's going to be minus 3 and a plus 2. Set each one of those equal to 0. And then solve, so that one doesn't give me any value. This one gives me x equals 3. This one's going to give me x equals negative 2. So here's a critical number, and here's a possible critical number. Alright, our first derivative test says we're going to test those values. So let's use our critical numbers. So we have a negative 2, and we also have a positive 3. Put them in order according to the number line. And we're going to test some values. We're going to choose different values. I'm going to choose anything to the left of 2. I'm just going to pick a negative 4. No particular reason, just to the left of it right now. Anything between a negative and a positive, the easiest thing to test is always 0. And then over here, I'm going to do positive 4. And test those values. Remember, you have some options there. You don't have to do the exact same thing. But now we're going to test those values. So I'm going to test the first derivative, f prom of x, and that's coming back up here, so that's just going to be 6x squared minus 6x minus 36. So we're going to test our first derivative at our interval. We're going to start with the first one. I'm going to plug in a negative 4 into the first derivative and evaluate. And in that case, I got 84, which is positive. So you just put positive there. Okay, the next one, we're going to take our first derivative. Everywhere there's an x, you're going to put a parenthesis, and then we're going to go evaluate that. This time we're going to test 0, which is our favorite because it's usually pretty easy. It means everywhere there's an x, plug in 0. And that's just going to leave us with negative 36, which just means this is negative. And we're going to do one more. F prom of our last test interval. Jot this down real quick. And now we're going to test it at positive 4. Plug in positive 4. Put that in your calculator and evaluate, and you get 36, which is positive. And so we look at this. This is increasing, decreasing, increasing. So by the first derivative test, it said if it goes from increasing function to a decreasing function, what does that mean you have right there? A max. Good. If it goes from a decreasing function to an increasing function, then right here we have a min, and you can also see that in your definition. So if it goes from a negative to a positive, you have a min. If it goes from a positive to a negative, so from a positive to a negative, you're going to have a max. Okay, so we say positive to negative, you have a max. So when we come back here and we see it, we went from a positive to a negative, or increasing to a decreasing, you have a max. If you go from a negative to a positive, or if we want to say it decreasing to an increasing, you have a min value. So we know that happens. Now we need to name it as an ordered pair, though. So we have a max at the x value of -2 and a min at the x value of +3. But let's find out those values. Remember, when we go back to find x and y values, you go back to the original function. So if I want to look what is f evaluated at -2, goes back to the original function to get the y value. So that's 2x cubed minus 3x squared minus 36x plus 14. And everywhere x is at, plug in a -2. And when you calculate that, we're going to get positive 58. And the other one we need to test is, well, we know we have a min here at 3. We need a f of 3. Everywhere there's an x, we're going to plug in 3 into the original function to find the y value. So we're going to plug in a 3 here. And that's going to give us a -67. So the way we wrap this up is we'll say we have a max at, which one was the max? Good, up here at -2. A max at f of -2 equals 58. Or you can just write the ordered pair. When x is -2, y is 58. That's the ordered pair of the max. Or you can say there's a min at the when f is evaluated at 3, which that equals f of 3 equals -67. Let me be careful there. Or you can give the ordered pair version of that, which is the x value of 3, the y value of -67 as your min. So we're going to want to come back over here to look at these. This next one is number 3. We can kind of walk through this one together. It's just another example. So the first thing we did here was find the first derivative and then set it equal to 0 so that we have critical numbers. That process has been the same, and that's going to continue to be the same. Now what I want to do is I want to set those up over here with -3/2 and +1. And the next step is to pick a value to the left of it. I chose -3. Pick something in the middle. Well, 0 is the easiest one between a negative and a positive number. And then pick 2. Okay. So the next thing that you're going to do there is we're going to test those in the first derivative. So here's my first derivative. I want to test it at -3. And I plug that in and I get a positive value. Okay, so right there, when I plug that in and I get positive, I just come here and put positive. Alright, then I'm going to do the same thing at 0. So I do my next test interval, which I take the first derivative, test it at 0, plug in 0. That's a nice one to do. I get -18, so I report that I got a negative value. And then I test f of 2, my last interval, plug it into my first derivative that I calculated above, and I got positive. So we're positive here. So after you do your test intervals, then you're going to have name this one is increasing, this one is decreasing because it's negative, and this one's increasing. Well, we say if you go from positive to negative or increasing to decreasing, that's the same thing, you're going to have a max value. If you go from negative to positive, or if you want to look at it like decreasing to increasing, That's a minimum value by our first derivative test. Well, now we've determined max and mins, but we only know the x value of it. So the way we go back and find the y value is to evaluate it into the original function. Plug in -3/2 everywhere there's an x to get the y value of 64. That's going to give us the ordered pair -3, -3/2 positive 121/4. And then, let's see. Actually, I don't know why I have 64 there. So then you're going to plug in your y value of 1. Plug that in and you get -1. So when x was +1, you get -1. And I need to go back and check what this value is supposed to be here, because I have it at 64 in this one, but 121/4 here. So I need to go back and double check which one that's going to be. And if I get a minute, I'll pause it and do it. If not, you can double check that for me. Okay. So the other thing that we can do is name intervals of increasing, decreasing, which I did in orange just for the practice of it. So if I was to say from -infinity to -3/2, that's increasing. So that's this one. And then it was also increasing from 1 to infinity, because that's where the critical number is. So 1 to infinity. And then it's decreasing on the interval in between -3/2 to +1.